Good afternoon, everybody. Welcome to our Austin Energy Green Building Seminar, Rethinking Water Infrastructure and Impact. Before we dive into the webinar, we will start with a few announcements of local events and put the direct links in the chat now. The U.S. Department of Energy is holding a press conference to recognize foundation communities for distinction in the Better Buildings Challenge. If you would like to attend, RSVP at the link in the chat. The SPEAR Policy Industry Workshop is next week. Join SPEAR members, partners, and allies for 2 days of energy dialogue. Exchange thoughts on the changing energy landscape, regional grid issues, record-setting demand, demand-side solutions, as well as national trends. Get more info and register on their website. The Austin Green Awards is accepting submissions through September 16th. Save the date for the awards night on October 23rd. The AIA Austin Homes Tour is almost here. Get your tickets to visit 9 homes on October 26th and 27th. All tickets include access to recorded architect sessions where architects of each home will discuss the design process and details about collaboration, materials, working with their clients, etc. These online presentations start on October 2nd. The IIA Austin Building and Closure Council Symposium is coming in November. Hear from nationally renowned leaders and local experts in building science. Featured speakers include Joe Stebrick, Graham Finch, Chris Hardy, and more. They are also having an optional tour and happy hour the day before. Check out their website for details. This seminar has been submitted for AIA Health, Safety, and Wellness Learning Units and GBCI Continuing Education Hours for lead professionals. Austin Energy Green Building will provide certificates of completion for self-reporting and reporting AIA hours for all of those who attended the webinar. All certificates will be emailed. A follow-up email with links to the recorded webinar and resources will be sent in a few days. Here is the AIA Quality Assurance slide. These are the learning objectives for our seminar today. If you have any questions during the speaker's presentations, use the QA window. We've scheduled a time at the end of the seminar to get those answered. For any that we don't get to, we will follow up after the presentation. So today we'll hear from our 4 industry professionals about ways to rethink our relationship with water. Presenters will discuss keeping water safe for humans while stretching the design and operational limits to conserve this precious resource. Presenters will also discuss equitable base incentive programs targeted to reduce the barriers to providing healthy, safe, reliable, and affordable water services to all communities. My colleague, Nancy Putman, will introduce our first speaker.
Hi, I'm Nancy Putnam. I'm introducing Dr. Olivia Smith. She has a Bachelor's of Science in Neuroscience from the University of Vermont, a Master's in Public Health in Epidemiology and Biostatistics from the University of Massachusetts Lowell, and a PhD in Biomedical Sciences from the University of Hawaii and Manoa, where she studied tropical medicine, medical microbiology, and pharmacology. She worked for the Peace Corps as a water sanitation and hygiene promotion volunteer in Peru, the World Health Organization on several malaria intervention projects throughout the Pacific Basin. Olivia now works as an invasive respiratory and infectious disease epidemiologist team lead for the state of Texas. where she is responsible for the subject matter experts on Legionnaire's disease.
Great, thank you for that introduction. Good afternoon, everyone. As Nancy mentioned, my name is Dr. Olivia Smith, and I'm the Invasive Respiratory and Infectious Disease Epidemiologist Team Lead in the Emerging and Acute Infectious Disease Unit of the Disease Surveillance and Epidemiology section in the Office of the Chief State Epidemiologist at the Texas Department of State Health Services. This is a brief outline of today's presentation. We will discuss what Legionnaire's disease is and how complex plumbing systems are at risk of contamination from the Legionella bacterium. We'll discuss Legionnaire's disease trends in Texas, followed by recommendations for Legionella prevention using water management tools, and finally leaving you with a few thoughts on balancing building practices with Legionnaire's disease prevention. So what is Legionnaire's disease? It's a respiratory illness caused by a Legionella bacteria. Infection can lead to a severe form of pneumonia and lead to hospitalization, and in extreme cases, death. People can get sick when they breathe in mist or vapor contaminated with Legionella. This can come from air conditioning systems. Sorry, oh, sorry, it wasn't presenting mode.
We've got it up for you.
Okay, thank you. Air conditioning systems, cooling towers, spas or hot tubs, fountains, ice machines, faucets, plant sprayers, shower heads, even dental appliances. Next slide. So you might be wondering why we're talking about respiratory disease at this webinar for builders, and why it's important. It turns out this bacterium is actually infamous in the complex building world. And complex plumbing systems as well. So why are these systems at risk? These complex plumbing systems in buildings pose a particular risk for Legionella growth due to several factors. These systems often have dead legs or unused pipes that hold stagnant water. Additionally, temperatures within these systems can settle into the lukewarm range between 77 degrees and 108 degrees, which is ideal for Legionella to grow. Finally, a biofilm, which is a slimy layer of bacteria, can actually coat pipes and lead to a protective environment for Legionella to grow. We need to consider how some building practices may unintentionally contribute to Legionnaire's risk. Water conservation measures like low flow fixtures can actually lead to stagnant water in the pipes, and energy efficient hot water systems can maintain those lukewarm temperatures to save energy. And those are both ideal for Legionella growth. Next slide. Here's an example of a pipe schematic. This is from an article in Microorganisms. We see the formation of biofilm that produces a great nutrient-rich environment for bacteria. This also important to note that the material of which the pipeline system is built significantly influences the appearance of high concentrations of bacteria. So previous literature shows us that the use of copper as a plumbing material has been shown to help reduce the risk of Legionnaire's disease, while plastic materials actually support bacterial growth. Next slide. Now that we know how this is spread and how complex plumbing systems are involved, we can look at what's been happening with this disease in Texas over the last 10 years. So using a statistical model similar to that of meteorologists and weather forecasting, epidemiologists are able to forecast disease trends. So here I ran a basic model to show the trend of this disease from 2012 to 2022, and we see an increase in Legionella cases in the recent years. The trend line shows us that the trends are increasing throughout the state, and I've also highlighted when we see the pandemic, the COVID-19 pandemic affected us, and we see decreases in cases, which could be due to a reduction in travel, which we see by the breakdown of exposures during the pandemic in the next slide. This figure shows us the exposure trends from 2020 to the end of 2022. In green, we see the healthcare associated infections. These cases occur in a healthcare setting or anywhere where care is given, including hospitals and assisted living facilities. In blue, this is travel associated infections. This means any case that's associated with travel or a hotel or anywhere outside of the person's home or workplace, and that's not in a healthcare setting. In yellow, we see sporadic cases. These are linked to any environmental exposure, including cooling towers, air conditioners, all the way to grocery store misters. And these aren't healthcare related or travel associated infections. The majority of cases are sporadic throughout the past 10 years. However, from 2020 to 2022, we do see a dynamic change. And that is due to the COVID-19 pandemic. So travel associated cases decreased in 2020 and have since gradually increased. This is, again, most likely due to those travel restrictions, changes to travel during the early stages of the pandemic. Next slide. We see the age distribution of cases of Legionnaire's disease here in Texas. This is over 10 years. The average age of somebody who had Legionnaire's disease is around 60 years old in 2022. However, as you can see from the distribution, people of all ages are impacted. This distribution is mostly due to population dynamics of exposure, as younger people don't tend to seek as much inpatient care, they don't travel as much, and there are less environmental exposures in the workplace, as they may not be working yet. The majority of cases, at 58%, are male. And we do see not really any difference in Legionnaire's disease between different ethnicities in Texas. Next slide. Legionnaire's disease is a growing concern in Texas, and as the data that I have just shown you from the Texas Department of State Health Services shows an upward trend in cases over the recent years. While the reasons for this increase are likely complex, it does highlight the importance of Legionnaire's disease prevention in our state, and increased awareness and improved diagnostics may be contributing to some of the rise. But the potential for underreporting and growing prevalence of complex plumbing systems in modern buildings are also a possible contributing factor. And some studies have shown that southern states may have an increased incidence rate due to warmer climates, but regardless of the reason for the rise, it's a cause for concern, and we do need to take steps to prevent Legionnaire's disease. Next slide. There are several things we can do to prevent Legionella growth in buildings' water systems. Some key recommendations are implementing a water management program that includes a plan for cleaning, disinfection, and maintenance of plumbing systems to control Legionella growth. The program should be adjusted to account for potential stagnation risks associated with green building features like low flow fixtures. Also, maintaining proper temperature is crucial. Hot water should be kept at or above 140 degrees Fahrenheit to kill any Legionella bacteria, and conversely, cold water should be maintained below 50 degrees to slow bacterial growth. And finally, stagnant water is a breeding ground for Legionella. Regularly flushing those low flow fixtures and dead legs in plumbing systems helps to prevent moving and prevention of stagnation. Next slide. So green building practices are crucial for a sustainable future, and also the prevention of Legionnaire's disease is quite important. The good news is we can achieve both goals by implementing additional measures in water management plans, like previously mentioned, increasing flushing schedules for low flow fixtures, ensuring water movement and preventing stagnation, regularly monitoring and adjusting water temperatures, and finally, utilizing Legionella-specific disinfection methods as part of the water management plan. And next slide. With that, I would like to thank you for your time and attention. Please feel free to reach out to our office via email for any Legionella questions. Thank you.
Thank you, Dr. Smith. That was excellent. Now I'm going to introduce Matt Freije. He has a Bachelor's of Science in Mechanical Engineering from Purdue University. Matt is the founder and CEO of HC Info and the content director for Lance, which is a cloud application for water management plans, data analytics, and training. He's a certified water specialist and an ASSE standard 1280 instructor. He has provided Legionella education and information since 1995. Thanks, Matt.
Thank you. as Olivia pointed out, it's important for anyone who is involved in designing or in managing buildings to know how to manage building water systems to be both healthy, particularly regarding Legionella and other pathogens, and also green. And the pathogen control has been talked about for a long time. We've had Legionella guidelines here in the US by the EPA, by OSHA, CDC since the 1990s. In Australia and the UK, they had actually regulations going back to 1991. And what really all of the guidance at that point agreed on, they didn't agree on everything, but what they agreed on is that building water systems should be managed to minimize Legionella. What they weren't necessarily in agreement on was the approach, but that changed largely, almost completely, with the introduction of ASHRAE 188, Standard 188, which was finalized June of 2015. And that standard provided a framework that is now supported by the CDC. It's consistent with what the World Health Organization outlined in 2006, with what the Veterans Health Administration has been requiring since 2014. And it's also the basis for actually all of the state and pending state regulations regarding Legionella. And what ASHRAE 188 does is it outlines a framework for managing cooling towers, whirlpool spas, plumbing systems in buildings that have certain risk factors, and other water systems that can either harbor or transmit Legionella. The study that my team did in 2021, which was presented at the Association of Water Technologies and also published in their journal, was a study of over 900 water management plans. And what we were looking for was to see the degree of implementation of those plans. You know, we knew these were the cream of the crop plans, very prestigious as institutions. They cared about their brands and cared about water management. They had really comprehensive water management plans. We wanted to see if they were implementing them. But what we found almost by accident was that the facilities that were keeping up with their control measures, they were keeping on schedule with their control measures and also doing more testing, found less Legionella. Legionella positivity was lower. The data was so clear, it was almost linear, that as the control measure compliance and testing increased, Legionella positivity decreased in the plumbing systems of those buildings. However, very few facilities were fully implementing a comprehensive plan. And these, again, were the cream of the crop facilities. If you were to look at all facilities that should have water management plans based on ASHRAE 188, the percentage that actually do is very, very low. And this isn't really, the state health officials began realizing this as well. So now we're getting more and more states with regulations. Some on this screen already have them. The ones at the bottom row, New Jersey, Pennsylvania, Nevada, have pending regulations. And what is also being emphasized, besides the water management procedures, or as part of them, I should say, is water quality monitoring. That's been even more emphasized in recent years. The Association of State Drinking Water Administrators, the CDC, Veterans Health Administration, the Joint Commission, which accredits hospitals, all emphasize or require, in the case of the VHA, regular monitoring of temperature, disinfectant, and pH. And then it's also been recommended by some of them to monitor turbidity and dissolved solids or conductivity at the points of use, which I agree is very, very important to detect conditions that have caused outbreaks before. So the overall objectives then for a water management program, that one's outlined in ASHRAE 188, is to protect health and life, to reduce the risk of pathogens, to promote employee wellness. Whereas in for green building initiatives, and when I say green building initiatives, I'm not referring specifically to what Austin Energy Green Building has recommended, or any other organization for that matter, but just in general what those programs typically entail. It's to minimize water and energy consumption. Some of the measures, though, conflict. So with the water management programs, as Olivia pointed out, flushing is part of most of those. So let's say in a hotel or in a hospital, they may have an objective or a control measure to to make sure all the outlets in the building are used at least twice a week, or once a week. It might be for commercial buildings. Hospitals, it's going to be typically twice a week that they aim for. So they don't, the only way to really manage that effectively, unless you have sensors, which I'll talk about in a minute, is to just flush all those outlets. So they do that while they're cleaning rooms, or just routinely twice a week, which of course uses a lot of water. It also uses a lot of energy because of the flushing of the hot water, making the water heaters work more. And then higher hot water temperatures as well, and continuous hot water recirculation uses more energy because of the pumps. And then, so those really aren't very green measures. And with green building initiatives, that like Olivia pointed out, flow restrictors are part of that. So you not only have reduced flow, which isn't good for pathogens, but those restrictors in some cases can harbor sediment, which provides nutrients and a safe haven for bacteria. Johns Hopkins has some interesting data on different types of flow restrictors and the effect they had on Legionella results. Then water reuse systems can increase stagnation, for example, rainwater catchment systems, and they are likely going to provide more nutrients in the water for pathogens than would water in the public health or public water supply. Some heat recovery designs can be a problem too, particularly if there is not a double-walled heat exchanger that's completely separating the heat recovery piping from the potable water system. But there are some synergies too, and my colleague David Swiderski and I wrote about this for Buildings Magazine about a year ago. And for example, minimizing biofilm and scale is really important to minimize pathogen risk, but it also reduces energy costs. Montana State University estimated with their studies that only 2 millimeters of calcium carbonate scale and biofilm can increase energy costs by 50% in a plumbing system. Minimizing surface area, like piping and equipment, is also important. Of course, that's green because you're just using less, right? You're also reducing friction in the system. Minimizing corrosion and stagnation sort of go together because stagnation can cause corrosion, microbial induced corrosion, or MIC, which according to microbial biotechnology, a paper published in 2021 that showed that at least 20% of corrosion is caused by MIC. So the other thing too is that when you minimize corrosion, you're lengthening the life of equipment. So you're using less. How can we do better? One is to use sensors or smart faucets to minimize unnecessary flushing. So instead of flushing everything once or twice a week, the sensors or the smart faucets will show you which outlets have been used less than what the team has set. So for example, in our software, we have a setting, well, you can select 120 seconds over 72 hours. That's actually the default. You can change it however you want. But if a faucet has not been used that 120 seconds over the last 72 hours, an email goes out saying you need to flush that faucet. So they're not flushing everything, only the ones that need it. Eliminating unnecessary fixtures and equipment and piping is, you would think they would just want to do that anyway, right, to save money, but buildings get over-engineered, and that extra equipment and piping and fixtures is additional surface area, and surfaces are where the biofilm develops. So you're preventing risk by reducing the types of equipment, and then of course you're using less, and you're also reducing friction in the system, which saves energy. And then to use sensors to monitor water quality, and by doing that you can alert yourself, particularly with events happening that change the water coming into the building, of conditions that have caused outbreaks. You can mitigate those conditions before somebody gets sick, but then also before you have to use chemicals for disinfection, or at least you can reduce the amount of chemicals that you use for disinfection. So it's important to do both, and in building water systems can be managed to be both healthy and green. Building owners need to be educated though on how to do both. Thank you.
Hello, everybody. I would like to introduce Rebecca Batchelder. She's a professional engineer and is part of the on-site water reuse and reclaimed work group engineer with the Utility Development Services Division at Austin Water. Her team is responsible for implementing the utilities on-site water reuse and reclaimed water initiatives through the ordinance development, plan review and permitting, and regulatory oversight. Rebecca has a master's in science in environmental and water resources engineering from Tufts University. She held various water resource planning roles in Austin and Los Angeles for the past 17 years. Welcome, Rebecca.
Thank you, Stephanie. Got to hear it twice. Let me share my screen here. See if it all, does that look good? Is it a full screen? Assume that it is. Okay. Well, thank you for the introduction, and thank you for those two previous presentations. They're really interesting and a good lead into this. You know, sort of talking about how, you know, the health and safety issues and how they impact green development. And now here we are out in the city of Austin, where we have an on-site water reuse program where we are trying to take into consideration human health and safety and making sure that we are both utilizing our resources efficiently and conservatively, as well as protecting human health and safety. So I will give a little background to our program, if I can figure out how to advance my slides. Give me a second here. There we go. So I'll give a little background to the program here, and then we'll go into some of the health and safety measures that we've got. So this picture may look familiar to some of you. This is our water supply reservoirs during some of our most recent severe droughts. So as we are all, I'm sure, quite familiar with in this group, water supply is of critical concern to our city with the growing population and climate uncertainty. So with these most recent droughts, we have had increased scrutiny on our water supply system and wanting to make sure that it continues to supply the generations to come. So with that, we implemented a planning process in the city of Austin called the Water Forward Plan. The original Water Forward Plan was adopted and approved by council in 2018, and they're in the process of updating it now. The intention is to have it be a kind of a living document that gets updated, and we check back in on it every 5 years. So it's a 100-year plan where we project our water supply out 100 years into the future, project demands as well as the supplies, considering the impacts of climate change. And then in kind of identifying where we might have shortfalls, trying to figure out strategies for how we will meet the shortfalls. So our plan is front-loaded with the conservation and reuse, and then out into the future, we're actually looking into the kind of the more capital-intensive engineering projects like aquifer storage and recovery to increase our supply. But at the beginning, we're just trying to extend out the supplies that we have and try and use them as efficiently as possible so that they last as long as we can before we need to build these really cost-intensive new supplies. So with that in mind, our group has been tasked with the reuse component, trying to get on-site water reuse a part of the city of Austin's water supply portfolio, really through requiring large developments implementing on-site water reuse. So as of April 1st of this year, we have a new requirement on the books, which is that any development over 250,000 square feet of gross floor area is required to implement on-site water reuse. We did a lot of kind of looking into how to most effectively kind of word this requirement. We want to make sure we understand it's a big new ask of developers. And so we wanted to make sure that we're really targeting it and getting the most bang for the buck. So we looked at a lot of different building typologies and what we came to, and a lot of different combinations of what we would require of people. We looked into gray water reuse, rainwater, AC condensate, as well as what different sorts of on-site supplies that water could be used for. And after a lot of analysis, we landed on any, as I said, any building over 250,000 square feet or greater, whether it be commercial, multifamily, or mixed use, is required to collect rainwater and AC condensate. And then what it is used for depends a little bit. We did break it down into two groups here. For the more suburban multifamily type developments where there's over 4 buildings and they're spread out far enough apart with a floor to area ratio of under 1, we only require that the on-site water be used to meet irrigation demand, because typically in those developments there's a considerable irrigation demand. But if it's a more compact development like a high-rise or mid-rise building, we require that it is used to meet irrigation demand, as well as indoor demand for toilet flushing, as well as cooling tower demands. So that is the requirement as it stands as of April 1st of this year. A little bit more about the typologies that we looked into. Again, there's a lot of different typologies, and reuse of this sort will look different depending on the type of building. So we've got high rises are in some ways sort of the easiest. It's all this stacked plumbing. Suburban, it's a little harder to both collect and redistribute. Again, that's why we kind of made this carve out for suburban multifamily. And then the mid-rise are sort of caught in the middle. It's probably we do require that they do bring it indoors, but it's a little more challenging. So that's kind of the cost impact is greatest for these mid-rise type buildings. But really for all of them, we find that there is a significant impact with limited cost impacts. And so now kind of bringing it back to the theme of protecting human health and safety, before April of this year, when this went into effect, for several years, we wanted to develop a framework to make sure that as we implemented this requirement, and we knew, recognizing that would mean a lot more of these systems online, we knew we needed to make a framework for how we would require these systems get designed and permitted in a way that would be protective of human health and safety. So in service of that, we relied a lot on the National Blue Ribbon Commission for on-site non-potable water reuse systems, where they have a lot of wonderful people like our first two speakers who really get into the weeds on all of the questions of microbial growth and potential for risk, and we established a framework to say, not just, you have to just treat all water and it has to be treated the same as if you were going to drink it. We wanted to recognize the opportunity that on-site water reuse provides in being able to use these sources of water that are relatively clean. It's not black water, it is rainwater and AC condensate, which are somewhat cleaner sources. And so we didn't want to go overboard on making treatment requirements, but at the same time, we did want to be protective. So we tried to sort of strike this balance. And part of that was recognizing the potential for contamination, or the potential for risk involving both the quality of the source water that you use, right? Air conditioning condensate is a different quality than gray water, say, as well as the potential for human exposure. So water going into a cooling tower, or non-spray irrigation versus spray irrigation versus toilet flushing. All of those have different potential for human health, human contact. So we developed this framework that said treatment is kind of a matrix of the treatment requirements that is based on source and where it's getting used. So if you really want to get into all the weeds of what our requirements look like, these are the sort of sections of code where you're going to find all of that for those of you who want to go there. Really, chapter 15, 13 is where you're going to see the bulk of both what we are requiring of these large developments, as well as the design and permitting requirements. So, design and permitting, that's where we're trying to be protective of human health and safety. It's where we outline all of our treatment requirements, all of our reporting requirements, all of our monitoring requirements. So all of that is trying to be managed through our permitting process. We recognize that the city of Austin's permitting process is already quite onerous, and we're really working hard to do everything we can to make it as smooth as possible. It's a whole new permit, and but we have developed a lot of materials on our website, which I believe has been shared in the chat. But we have you know, a engineering report template, we have design guidebook, we have a water balance calculator, just a whole lot of resources on our website. And it's a good resource to try and allow people to design these systems efficiently. Yes. Oops. Sorry, my computer went to sleep. Here we go. So these are some snippets from our design manual. These show kind of the 3 systems that we anticipate encountering most frequently. So we have a AC condensate to cooling tower type system. We have a rainwater to non-spray irrigation system. And both of those we consider to be non-LRT systems. I haven't introduced that term. LRT is log reduction target. So basically we have water quality treatment requirements. You have to treat the water before you can use it. But these systems, we do not require pre-treatment. One, as I mentioned before, it has to do with the source water and the usage. So with the AC condensate, it's a very clean source, so we don't require that it be treated before it goes into a cooling tower. And rainwater, because it's non-spray irrigation, we consider the public exposure to be limited enough that we don't require treatment. However, it's important to note here with the cooling tower, that is certainly a concern with Legionella, I'm sure the first 2 speakers are thinking right now. So there are still requirements for recirculation and treating with a biocide with the cooling tower, and that's a requirement for any cooling tower system, whether it be fed by an on-site water source or not. And then we have this one at the bottom, which is the one we anticipate encountering most frequently, because this is what our mandate requires. It's rainwater and AC condensate collected together and used for indoor use. So for this one, you'll see we do require treatment. Most people are getting a treatment for pathogens, so that is usually UV reactors are used to achieve the treatment requirements. You need some pre-filtration before it goes into the UV reactor. Then you have a treated water tank, and there is a chlorine residual that's required once it goes into the building, again, to try and make sure that, you know, post-treatment it stays, you know, we limit microbial regrowth. There's also the alternative water permit, and this is not actually my department, this is Special Services Division. You know, my department is focused specifically on the water itself that you treat on site and what are the requirements for that. Special Services is concerned about Austin Water's drinking water supply. So they're concerned about backflow prevention and cross connection. So you'll see in this figure that on-site water reuse systems require a separate meter to back up the systems. For when we run out of on-site supply, you need a potable backup. That backup meter will require a reduced pressure backflow assembly right at the meter. And there will also is a requirement for the backflow prevention at the potable water meter, the water that's feeding the potable fixtures. So all meters require a RPZ when there is alternative water on the site. Special Services Division is also checking for cross-connection testing. They want to make sure, again, that there's no potential for contamination between the on-site water and the potable water. So that's their department. We also have signage requirements, so we don't get people drinking out of toilets thinking that it's clean water. And then we have ongoing monitoring requirements. So there will be the conditional startup mode where there's more frequent monitoring, where we're really making sure that these things are operating the way we expect them to. And there's monitoring for coliform. And if it's a gray water system, there would be monitoring for BOD. You will need continuous monitoring of the chlorine residual. And again, kind of measuring the effectiveness of the the LRT, the log reduction target. So that's conditional mode. And then once everything is sort of shows that it's operating the way we anticipated it operating, we move into final use mode. Then you can go down to monthly monitoring, and then there's annual reporting to show kind of how these things are performing. There's also, again, back to the Special Services Division and their backflow prevention and cross-connection testing. They require annual testing for the backflow prevention and cross-connection testing every 4 years. And that takes me to the end of my presentation. So I will come back for questions later. I will try and stop sharing here if I can.
All right, thank you, Rebecca. That was great. Our next and final speaker will be Daniel Cavazos. Daniel is a dedicated LEED GA certified water conservation professional with an educational background in business administration and over 2 decades of experience in the environmental stewardship field. As the conservation program supervisor at Austin Water, he leads the customer programs team, focusing on providing valuable rebates and incentives to help residents and businesses conserve water. With a passion for education, Daniel plays a crucial role in raising awareness about water conservation practices among Austin Water customers. Today, Daniel will share his insights on the critical topic of equitable water, drawing from his extensive experience in developing and implementing water conservation strategies for diverse communities. So whenever you're ready, Daniel.
Hi, my name is Daniel Cavazos, and of course I'm talking about equitable water. I want to make sure everybody can hear me. Can you hear me? Yeah. Okay, so I'm going to be covering a few things about equitable water, talking about the equitable water roadmaps and strategies, looking at multifamily assistance and single family assistance, and then kind of how we get over some of the technology barriers that we've discovered as we implement our water conservation program. So the first place that I want to start is discussing the roadmap of equitable water and how it informs our programs and the way that we make decisions. So the main thing that I want you to take away from with this picture is that this begins at a high level with Austin, with the city of Austin. So water equity really interconnects the environmental and social issues from drinking water quality, accessibility, reliability to affordability. There's a really big kind of field here as we're talking about equitable water, and we can really talk about anything from floodplain management, water quality, recreational use, and a lot of other things. But I really want to narrow the scope so that we're getting down to the strategies that I need to implement in order to ensure that we are equitable in our treatment of our customers. So I'm going to begin with the climate equity plan from the city of Austin. And in the climate equity plan, it talks about the 2030 goal of equitably achieving a water demand of 152,000 acre feet per year for community-wide demand. And then that kind of informs a lot of the other programs and documents that we put together. And of course, again, I'm really talking at a high level because Rebecca had mentioned the Water Forward Plan, and then some may be familiar with the Water Conservation Plan or the Drought Contingency Plan. And all of those are actually brought into to the process to inform kind of our strategies at water conservation with my team, the customer programs team, in developing and administering our programs. But we also go a little more in depth in that as we are creating our programs and we're creating these other items to incorporate equity lenses that inform our programs. And what I mean by an equity lens, I mean we try to use two different kind of questions or big picture items in mind, which First is distributive justice, which pertains to the fair distribution of benefits and burdens within a society. And the second is procedural justice, which focuses on the fairness of the process by which a distributive decision is reached. And we use those lenses as we are creating our programs and as we are interacting with our customers to ensure that we are equitably servicing our customers. So the next place I need to go is to the Austin Water mission, as it kind of trickles down and coming closer to where I'm at. And our mission at Austin Water is to provide safe, reliable, high quality, sustainable, and affordable water services to our customers so that all community needs for water are met. And what I want to really highlight is the places that that are in bold text. Those are essentially the pillars or the characteristics of equitable water. It's safe, reliable, affordable, and this community needs for water are met for all. All community needs are met. So we actually see within Austin Water's mission kind of this foundation of equitable water, and the characteristics are there from the kind of the leading charge of what we do within Austin Water. But again, I still need to narrow it down even more as we begin to develop our programs to how we're going to implement this with our customers. And so for me, when I think of equitable water and I think of water conservation, I think of it as water conservation and equity efforts and our focus on ensuring universal access to safe, affordable water through sustainable management practices, addressing socioeconomic disparities, and balancing present needs with future resource availability. That's how I define it as I am looking at these goals and trying to understand how we're going to implement our strategies and programs to meet those needs. So we do have strategies for equitable water. These are, if you can imagine, buckets for programs that we use. We have our commercial and multifamily program, our Bucks for Business program. And I'm going to go a little bit in depth in that here in a moment. And then one where I'm sure a lot of people are familiar with is the residential program. And then we have accessibility, where I'll talk about that in a moment also. But I want to go back to the residential programs, because when you think of a water conservation program, a lot of times our focus goes to residential programs. I saw a newscast just this weekend, and the meteorologist was talking about outdoor water usage, and he used a number: 70% of single-family residential water is used for outdoor water use, and he mentioned irrigation systems specifically. And the number that I'm a little more comfortable with is about 60 to about 65% or so of our water usages for outdoor water, for watering your plants and your trees and your grass, etc. And so a lot of times when we're thinking about a residential program, we're thinking about kind of minimizing that water use, about removing turf grass and putting in native and adaptive plants, about the irrigation upgrades and trying to get away from a lot of the inefficiencies that are incorporated in irrigation systems. And those are great programs. I mean, you want to tackle the 65% or 70% if you're the meteorologist. All of those are really good programs. But what we've come to see and what we've realized as we've kind of incorporated many of our programs is that there's a high upfront cost for those residential programs. In order to remove 500 square feet of turf grass, which is the lowest amount in order to get into the current lowest amount to get into our WaterWise landscape rebate program, which we have at water conservation. But in order to get into there, and as a do-it-yourselfer to remove 500 square feet, and that's renting equipment, that's purchasing plant material and items like that. you have to come out of pocket about $400 for that program, and not everyone has $400 to enter those type of programs. So we really have to be creative. We have to look at the different methods and different strategies in order to really make these programs more inclusive. But more than that, look at these strategies and these programs to kind of determine, are there other things that we can do that can kind of broaden our perspective so that we can find water savings in these different customer groups in different areas. And I think that we've been pretty successful. So what I want to do is on the next few slides is to share some case studies of some successes that we've had recently as we've tried to implement this equitable water strategy within a broader customer base. And so this first one, we actually used our Bucks for Business rebate program to assist affordable housing and multifamily. And when we were kind of thinking about all of this and trying to find the opportunities, it kind of stuck in our head this AWE Alliance for Water Efficiency 2017 report that mentioned some of the best opportunities for water efficiency investments are in lower income areas where water distribution infrastructure has not been adequately maintained or replaced, or where household and commercial appliance stocks tend to be older and less efficient. And it's really that end result about the older and less efficient. And it's not just those appliances and stocks, but it's also the fixtures and shower heads and even toilets. And so as we begin to focus on those things to try to find opportunities where we can really find those water savings, what we were able to do was to partner with a housing authority, with the city of Austin, or HACA, and we were able to show some really meaningful investments with our low-income customers. And through our rebates and incentives program, we were able to successfully make changes that saved a substantial amount of water while also maintaining minimal impact to the residents that benefited from these retrofits. And the retrofits included some fixtures, they included shower heads, they included new technologies for toilets. And through this, we've actually saw a decrease in up to 40% of indoor water usage. And it was pretty significant. We actually saw this average of 40% in the 271 affordable housing units that we partnered with HACA in retrofitting. So we're very excited about this. We thought that it was a really good program, and we were wondering if it was something that was replicable. If we could take the lessons learned and find some other customers and other groups so that we can implement the same types of strategies. And what we were able to do was to also work with the American Campus Communities and the UT West Campus section and implement a lot of the same strategies, looking at fixtures, looking at toilet retrofits. This time, though, the savings were not as dramatic. Instead, we have a 20% decrease in water usage. There was substantial savings for 14 of the 16 properties that were retrofitted. And when we took a deeper dive into this to try to figure out kind of what were some of the areas where those two properties were not seeing some of the same savings as the other 14, what we realized is that there was two specific periods where their water usage was increasing dramatically. It was move in and move out. When students were moving into dorms and when they were moving out of dorms, we only suspect that there was a lot of cleaning that was occurring. Not sure why it was only 2 of the properties out of the 16, but it kind of seems as if for those 2, there was a lot of cleaning that were occurring and moving in and moving out. So now we have another strategy to be there during move in and move out to really speak with students as they're coming in, to have information available to them, and to kind of make them cognizant and aware of their water usage during that time, hoping that we can influence some behavior so that we can bring that consumption down a little bit and really see the the water savings that we have in many of our other projects that have gone through this type of program. We also have a single-family residential assistance program. And here we actually assist residential, it's a residential plumbing repair program that assists low-income customers. And we assist low-income customers with the repairs to leaking pipes, toilets, water heaters, and other plumbing issues that our low-income customers would normally not be able to afford to repair. These repairs not only save a substantial amount of water, but it addresses health and safety concerns and elevates the quality of life for our most vulnerable customers. I mean, if you can imagine having a system that's just, well, let's just say that it really does help out, that you have running water, that your wastewater system is working correctly and not leaking in areas, and it's freeing up those residents, those homes, to be used by families. The program has shown success in lowering customer bills at times by half, and saving customers hundreds of dollars in repairs that they would not normally be able to fix on their own. And the great thing about this program is that we actually implemented it with a partnership with a local nonprofit who assists with the application process. They help to gather the needed documents and information to complete the application. The local nonprofit partners with the resident to help them throughout the process to ensure that they don't get overwhelmed and that all of the repairs are met. As I said before, there's been substantial savings with this because not only is it saving on the water bill, but it's also saving on wastewater and even energy costs. So there's significant savings, and it has a wonderful positive impact to these customers. This is another one where we're really proud of the things that we've been able to do as we've been able to implement a lot of these equitable water strategies. And then we also have some barriers that we have been looking to address. Some getting into some technology solutions. So recently we pivoted to online forms that streamlines the application process. And part of the way that we came about this was due to COVID. During COVID, we actually had a decrease in some of our applications, especially in our free tools that we distribute to single-family homes, where they can receive aerators and shower heads, as well as toilet dye tabs. They can also receive a free pamphlet that gives them information on how to make these repairs and sometimes diagnose these issues. It's a really good tool that can kind of take them throughout the process of identifying and repairing common household issues. And so prior to making changes, where we began with where we implemented this online portals to submit applications, the program was saving around 2 million gallons per year. That was in 2022, but then we implemented the program, and now we're up to almost 14 million gallons in 2023. It was a 600% increase in the participation for these programs, and so it kind of jump-started a lot of what we were doing to do more of these streamlining projects, and getting more into the online portal to help the remainder of our customers, because again, it's lessons learned and we see the effectiveness of it. Another thing we do, we work with AE to test in-store pilots programs, which these are coupons, so that again helps with that front end cost so that when you're purchasing conservation devices at local retail stores, local like Home Depots and Lowe's and things like that, you can just use the pilot program, which is a rebate coupon. And then, of course, people may be familiar with the My ATX portal, which is our smart meters that enable real-time tracking of water consumption and promotes responsible water use. The My ATX portal notifies a homeowner through push notifications of leaks and breaks, and the portal can save customers money by allowing them to identify leaks faster and get to those repairs. And it's free for all. It's not just limited to a specific sector of the community, but we make it available to everyone. And we really highly suggest that people sign up for the MyHAX portal to be able to understand their water usage. And then finally, we like to get out into the community. And here I have one of my coworkers in this picture, Anita, who speaking to one of the customers at an event where we go out, we get feedback from the customers, we hear about our programs, we try to determine what we can do to make them more accessible, what we can do to be able to make these programs easier through the process, the application process, the rebate and incentive process, all of it, and try to talk to them to get the ideas to make these programs a little bit more easier for everyone, and also to make sure that we're using the right programs, that we're actually meeting the needs of our customers as we're trying to implement these strategies for cost and water savings. So that's my item. That's kind of how we go from that high level of taking this charge from the city of Austin and bringing it down to kind of the brass tacks to where the rubber meets the road, and implementing the strategies that's going to include equity in the things that we do and with our water conservation programs. Thank you.
Alrighty, thank you, Daniel, and thank you to all of our speakers, as that concludes the presentation portion of our webinar today. We can now move into our Q&A section. So if everyone could put any questions that they thought of during the presentations in the Q&A box down below, that would be great. And we can just get started with some questions that I've filtered through already. We had quite a few questions come in during Rebecca's presentation, but all of our presenters feel free to chime in as we go along. So starting off, does a UV light filtration system eliminate Legionnaires bacteria from water stored in a cistern that may have water in it for a few months? And as a follow-up, what is the best recommendation for purification of rainwater stored in a cistern?
Yeah, UV reactors can treat Legionella, though I might leave that to the experts on Legionella. But I'll just say, I guess from our perspective at Austin Water, that we require treatment. We are sort of agnostic as to which treatment you choose, as long as you're able to achieve the log reduction targets. So we allow for chlorination, UV reactors, ozonation. We allow for a variety of different treatment options.
UV definitely will kill Legionella if it's flowing through the UV unit, and the UV unit is sized appropriate to the flow. It will kill it. It's not effective throughout a large plumbing system because it doesn't provide a residual disinfectant. And I don't know. I don't recall hearing of anyone using it to disinfect a large tank. I'm not saying it wouldn't be effective. I'm not so sure it would be very efficient. Chlorine, I would think, would be more efficient, but I don't know.
I mean, the idea is not necessarily to treat the whole tank. It's sort of treated. It's usually the way that these systems are designed in the city of Austin is to treat kind of enough for a day, and then then it gets into a day use tank that is with water that has been treated by UV, and then after it leaves that tank, that's where you have to add a UV residual if it's going to go into the building so that there is, I'm sorry, not UV residual, chlorine residual, so that it maintains some capacity to prevent regrowth of Legionella.
All right. Our next question was, are microplastics now monitored in our drinking water? Is there any treatment planned or happening now?
I don't know who that is directed at.
I believe it was directed at you, Rebecca, but again, feel free. For
Yeah, I mean,
anyone to chime in.
I'm don't manage the city of Austin's centralized water supply and what they treat for. We do not require monitoring for microplastics for the on-site water reuse systems.
Okay. The next question was the ordinance. Does the ordinance require reclamation and reuse of the wastewater?
So I assume that that's in reference to when you say wastewater, we're talking about like black water from a building or gray water, water that's coming out through the sewage pipes. You're not required to use that water. You can, but that's how we do it. We have at the Permitting and Development Center, we have a system that is treating the whole building as black water. It treats it and sends it back into the building for toilet flushing. The treatment requirements are, as you can imagine, much more extensive to get the required water quality to go back into the building from wastewater.
Okay. Are there any concerns with Legionnaires or other illnesses with AC condensate?
Certainly, there are concerns with that. That's in a, if you are putting the water back into the building or into a cooling tower, we do require, so if it's going to any on-site water that is going back into a building, into these plumbing systems that as it was described, plumbing systems have a way to harbor Legionella if you're not careful. So those systems, we require chlorine residuals. For a cooling tower, any cooling tower, regardless of whether it's fed by on-site water or city water, has to have a system for treating for biological contamination. So we have a biocide treatment, and so that would apply to us as well.
Yeah, as Rebecca pointed out, you definitely need to have backflow prevention between any non-potable and potable system and treat systems like cooling towers that can expose. But I think what they might be asking about is the condensate that drips into pans from HVAC units, and those get talked about. They have been, but they are a pretty low risk for Legionella. For one thing, they're below the temperature where it's typically going to grow, and most of those systems don't have fans powerful enough to aerosolize the water that's in those pans. But it's still good practice, just indoor air quality practice, to keep the pans dripping, leak free of slime and so forth.
Okay. Does an individual homeowner installing a reuse system need to go through the same permit process?
No, our permitting process is only for commercial properties. If you are above 500 gallons or have a pump on like a rainwater collection system, that will trigger the Special Services Division with backflow prevention and cross connection and whatnot. But our permitting process with the engineering report and all of that is only for commercial buildings.
Okay. And then Rebecca, where does one obtain the design manual that you mentioned?
So I believe our website was posted in the chat at one point. Yeah, it's the on-site water reuse systems. That will have, I saw other folks were asking about chapter 1513, so that's linked on that website. The design guidance manual is linked on that website, along with a whole host of other materials that you folks might find useful.
Okay. Daniel, in the vein of considering other measures, have you looked at evaluating investments on the basis of the replacement cost of water supply rather than on the basis of the current price being charged?
I think I'm going to say I think. Okay, let me place this disclaimer there. I think we do consider that, especially as we're looking at kind of the water forward plan and some others when we're looking at conservation measures. But as far as the way that we implement our water conservation programs, the rebates and incentives, we don't really look at that. We're just looking at the way that we can reduce water usage, and that's pretty much our goal there.
Okay. Does Austin Water offer reviews or comments regarding water saving claims for products such as smartwatervalve.com?
I'm going to think that's another question for me. No, we do not. No, we don't kind of put our stamps on them or or anything like that. So no.
Okay. And I think this links back to what we were discussing earlier. Can just filtration take care of Legionella in a rainwater system that also takes condensate water and pumps that into a home for domestic water?
No, so filtration will not treat for Legionella. So I think the earlier question said something about UV filtration, which is a little confusing. It's a UV reactor. And then you would need to for a UV reactor to function as intended, often some pre-filtration is required, right? You can't have murky water coming into a UV reactor. It inhibits its functionality because the light needs to shine through all of the water, essentially. So the UV reactor will treat for Legionella, but a filter that's just taking out solids won't effectively treat for Legionella.
Okay. Olivia, has there been any disparities in how Legionella affects lower income groups?
Great question. We right now there hasn't been much research onto that in Texas, and based on, I guess, a lot of the exposures come through employment, a lot of workplace exposure. I don't have any answers on underserved populations or low income. I don't have any answers, unfortunately, for you on that, but we do know that a lot of cases do come through places of employment. There have not been any disparities that we've seen based on ethnicity or race, but we have not looked into directly on income. That would be a wonderful variable to add.
Okay.
A good source for that, by the way, would be the CDC's MMWI reports. They have broken down by some of those by number of metrics, and that might be a good place to check.
Yes, nationally, absolutely. Unfortunately, Texas doesn't have much data on that, but if I would be happy to send out some of the CDC data for national data.
Okay, thank you. And a question for Matt. Of the states who adopted ASHRAE 188 plumbing code, have there been any unique outcomes like pushback from developers or reduced incidence of Legionnaire's disease?
There isn't good data on the outcome. New York's had regulations for the longest period of time, since 2016, but their regulations, other than healthcare facilities, pertain only to cooling towers, so it's not really a good test. And there really isn't the data yet to show one way or another whether it's been effective or the level of implementation yet. Most of the regulations are, even though they may not be new, like Virginia's had regulations for schools that have been in effect for a while, but not enforced. So not much has been done. And hopefully that data will come.
Alrighty, I think that concludes our Q&A portion, as I don't see any more questions in the box. So yeah, I will hand it off to Nancy to close us out.
There's a link in the chat for taking a survey on this, and we'd like to thank all the speakers that joined us today. It was an excellent presentation. You will receive a certificate if you attend the entire webinar today. Those should be coming out here within the next week. Thank you very much.